Hey, chi-squared problem set, page 1. 300 people were interviewed and asked which genre of books they mostly read. The results are given below in a table of observed frequencies classified by age. Okay, so just make sure that you remember that this part is the actual table and everything else is totals. So when you look to see what side of the table it is, it's 3 by 3, right? Okay, now perform a chi-square test at the 5% significance level to determine whether the genre of books is independent of age. Okay, state the null hypothesis and the alternative hypothesis. Okay, null hypothesis. Whenever you state the null hypothesis, basically what you're going to say is that the two factors are independent. That's what you would say. Which factors? Oh, well, genre of books and age is independent. Okay, that's all you say. That is the null hypothesis. Now it says alternative hypothesis. Alternative hypothesis, H1, is just equal to the opposite. So, but you don't say dependent. You say genre and age are not independent. Okay? You don't say you don't say are dependent. You just say are not independent. Okay? All right. Then you go to the next one. Show that the expected frequency for science fiction in the 26 to 50 age group is 42. Okay, so what they want you to do here is they want you to hand calculate the expected frequency for, let's see, they want to do it for the 26 to 50 age group, and they want to do it for the age science fiction. Okay, so basically it's this position of the matrix. Okay, so to do that, we are going to show that, hey, we can find 38, the expected, not 38, but the expected frequency for this position. We can find it by using 97, 130, and 300. And the way we do that is we use a multiplication. We're going to say this fraction, 130 divided by 300, times 97 divided by 300 times 300. And if we multiply all this together, these cancel out, we are going to get a number close to 38, but not exactly 38. It's going to be 130 times 97 divided by 342. Oh, what do you know? It's 42. Yeah, actually, they told us the answer, remember? So yeah, the answer is 42. How do you calculate it? You calculate it that way. Okay, so we just showed that the expected frequency is 42. Now how, okay, and then we'll go down here. It says write down the number of degrees of freedom. Remember degrees of freedom? Degrees of freedom can be calculated by reducing the number of rows and number of columns by 1 each, and then you end up with 2 by 2, and you multiply them together, you get 4. So the degrees of freedom is 4. Write down the chi-squared value for this data. Okay, now they're getting the part where you actually need to use the calculator. So how do we use the calculator to calculate chi-squared? We do second matrix, and then let's say we're just going to use matrix A, which is, oops, that's not the way you do it. You use second matrix, and then you go to edit. And edit is going to allow you to actually input a matrix. And what kind of matrix do we want? What size? 3 by 3, of course. We know that it's 3 by 3. Okay. And then we're going to input the numbers in here. So the numbers that are there, we're going to input, and I'm just going to do this offline. Okay, so you just navigate through this table using the arrows. And the last column I'm going to do now, it's 41, down arrow, 38, down arrow, and I'm just putting the observed frequencies in here, not the expected frequencies, just the observed ones. The calculator is perfectly capable of calculating the expected frequencies when you give it the observed frequencies, because it's just that simple formula we just showed, right? Now, to execute this, we're just going to do, now here it says second matrix, we did that. Enter matrix size and data, we did that. Now we're going to do stat test C. Stat tests C See, that must be all the way on the next page. There we got chi-squared. What do you know? And our observed matrix, we put in A. Expected matrix, yeah, you can put it in B for me. And we're going to calculate. Okay, and then it gives us all these interesting details. So it says that the chi-squared value is 26.9. And then it says the critical value is this, and it says the p-value is 2.07 times 10 to the negative 5. And it says degrees of freedom is 4. We already calculated that, right? So the calculator actually calculates degrees of freedom for you too, but you already know how to do that really easy. Now, the critical value, it says, is 9.488. The critical value is the value that you compare to the chi-squared value. So you're going to compare 26.9 to 9.488. Now remember, 26.9 shows dependentness. So since it's greater than 9.488, that means that the data is dependent. And so you can reject the null hypothesis. So the result is you can reject the null hypothesis because 26.9 is greater than the critical value 9.488. Okay, actually it's not 94.88, it's 9.488. Okay, yeah, so we rejected the null hypothesis because of that. And you can also look at the p-value. The p-value can also be used to do that. You see how the p-value is really small, 2.07 times 10 to the minus 5th? It's very small. It's actually smaller than the significance level. Significance level, remember, is 5%, or also known as 0.05, okay? And so since 2.07 10 to the minus 5th is smaller than the significance level, then you can also reject it. But you only need to look at the critical value compared to the chi-squared value, or the significance level compared to the p-value. Okay, so p is always compared to the significance level, and except for the p-value, when it's below the significance level, then you reject. And when the chi-squared value is above the critical value, then you reject. So that's kind of hard to keep straight, and that's something you kind of have to memorize. All right? All right. Number 2. Tyne was interested in finding out whether natural hair color was related to eye color. He surveyed all the students at his school. His observed data is given in the table below. So, again, just so that you don't get confused and think that the totals are part of the table, I'm just going to put a square around the table. Perform a chi-squared test at the 10% significance level to determine if hair color and eye color are independent. Okay, so state the null hypothesis and the alternative hypothesis. Now remember, the null hypothesis, all you say is that null hypothesis, all you say is that the two factors are independent. So hair color and eye color are independent. And then the alternative hypothesis, written H1, is that the two factors, hair and eye color, are not independent. That's all you say. Okay? And that's it. B, find the expected frequency of a person having blonde hair and brown eyes. So now what we're going to do is we're just going to, they want us to find the expected frequency. Oh, okay, no, they want us to find just one. So the expected frequency of a person with blonde hair, and brown eyes is going to be that position. So, okay, we're going to use the 90, we're going to use the 85, and we're going to use the 227, okay? And in this case, they didn't say, let's see, the last time, for example, they asked us to show that the answer is 42. So we had to do the calculation. In this case, they just say find the expected frequency. If it's just find the expected frequency, the calculator can do it for us. Basically what they want is the expected frequency for this position, right? So let's just do it with the calculator. We'll do everything with the calculator. And to do it with the calculator, all you do is do a second matrix, second matrix, second matrix. And I'm going to put this one, let's put it into matrix D so that we can save our work from before. And so we're going to edit, and we're going to put it in matrix D. And in matrix D, I'm going to make a 3 by 3 matrix. 3 by 3 matrix. And I'm going to put in the contents of this matrix, and I'm going to put them in one by one, hitting the arrow keys 30, 5, 8, and 9. Then I go to the right and go to the top again. I'm going to do 43, 27, 20. 43, 27, 20. And then I go to the top of the third column. I'm going to put 12, 48, and 25. Okay? And that is the matrix, 3 by 3 matrix, right? And then to make the test, I'm going to do a stat test, and then I'm going to go down to C. C, it's really far down there. Enter, and then the observed matrix is going to be the D. No, what did I say? The C matrix? No, it's the D matrix, right? And the way I put in the D matrix is going to be, I'm going to say, hey, second matrix, and then I go down and I do names, and then I'm going to go down to D, and then I'm going to hit enter, and then I'm going to go to expected, and now I want to put that into E maybe. So I'm going to go back and I'm going to find second matrix, and then I'm going to find the name. I'm going to go to E. Okay, so it's going to put the expected values into E, and I'm going to need the expected values this time because it asked for information about the expected frequency of a person with blonde hair and brown eyes, right? Okay, so now I'm going to write these values down because these are very important. The chi-squared value is 44.3. This is already the answer to that, by the way. It's like very quick, right? 5.56 times 10 to the minus 9th. And then the degrees of freedom is 4. I don't know if they asked us to do, yeah, here's the degrees of freedom, so we'll put 4 there. Write the chi-squared value for this data. The chi-squared value for this data is that, right? And then they asked us for the frequency of a blonde person having blonde hair and brown eyes, the expected frequency. So we can find that by looking at matrix E. Remember matrix E? Matrix E actually has all that there. So here's matrix E, and to see the whole thing, you have to kind of go to the right. Okay, and let's see, we've got to go all the way to the right. And then look, the blonde and blonde and brown eyes is the top right value, and the top right value is 33.7. So, and we can like write them all down here, but they didn't ask us for the whole matrix, although we could write the whole thing here. So the expected frequency of a person with blonde hair and brown eyes is 33.7 actually. And if you wanted to calculate that, you could calculate it by taking 90, 227, and 85. What you would do is you would have 90 divided by 227 times 85 divided by 227 times the total number of people, which is 227. And if you multiply all that together, you're going to get 33.7. Okay? So if they asked you to show it, then you show this calculation. If they just ask for the number, you can use the calculator and check what they put in the expected frequency matrix. And here they did not ask if you are going to reject the null hypothesis, but let me show you how you do it. You check, is chi-squared 44.3, is it greater than the critical value? And actually here they didn't give you the critical value, so you can't check. But actually the p-value, you can always compare to the significance level. Okay, so the significance level can be compared to this p-value, and yes, this is indeed smaller than the significance level, It's much smaller, in fact. So we will reject the null hypothesis. So in the end, hair color and eye color are not independent. Okay, that makes sense, right? We know that hair color and eye color are not independent.